Okay, so let's look at these slides real quick. I had to get rid of one of your problems because it talked about what's the distance from here to here. I didn't want to get into that. I just didn't care. What the distance is between where you think it should be and how much it's displaced through the thing. I don't. Doesn't matter to me. But anyway, so here, mirages are formed, or as Bugs Bunny would say, mirages are formed by light refracting through air of different temperatures and therefore different densities. So you got the larger end on top and the smaller end on the bottom, and so it looks like there's actually um, the the vision that they see actually reflects back, and it looks like we're seeing this car on the road surface here. But here's some actual. This one I like because this kind of shows why the the ha. This shows this is an illusion. This is an illusion. Okay, this is an illusion. Just like in the one pictures we were seeing, the actual body of that person was not over there. The actual body was underneath, you know, underneath the underneath his head. So the straw is actually here. All right, but it looks like it's over here. And when we go and put our finger and touch it, our finger diffracts over there and goes that way. All right. So now let's go. But this leads to kind of something kind of cool. All right. This leads to fiber optics and total internal reflection. It's good stuff. In other words, look at this. Look at this. Here's the idea. Let's go back to our diamond and let's look at light coming out of it. Okay. So we're going to draw the same thing, but now we got the diamond on top. So N1 is equal to 2.42. Okay, and let's say we've got this coming in at 30 degrees, and it's going to hit air. N2 is now equal to 1.00. It's going to hit air. All right, so it bends way out here. If we get the angle right, then theta 2 is going to be huge. If we get the angle right, can you see that if I just get this angle just right, if I can get this angle right here of the light coming out of the diamond just right, it's going to go right along here. In other words, I'm going to get theta 2 is equal to 90 degrees. So let's do that. So we get N2 sine, or N1 sine theta 1 is equal to N2 times the sine of 90 degrees. What's the sine of 90? Quick, 1, right. So N2, and so the sine of theta 1 is equal to N2 over N1. Now notice N2 must be less than N1. You can only get this total internal reflection when you do it this way. All right? When N2 is less than N1. So that diamond, so let's figure out well, right here we had N1, we'd had 2.42 times the sine of 30 is equal to 1.00 times the sine of theta 2. I didn't know what theta 2 was, so theta 2 is equal to the inverse sine of 2.42 times the sine of 30 divided by 1. Now, if I get an error, so I've got 2.42 divided by, sine of 30. Oh, look at this. Divided by 1.00. This is great because I screwed up. Error. I've got an error. It's not going to work. This means it's totally internally reflected. It's coming back. There is no theta 2 over here. There is no theta 2. internal reflection. Because here, we're going to find that the internal reflection is equal to the critical angle. The critical angle is equal to the inverse sine of N2 over N1. And the inverse sine, so I'm going to take the inverse sine of, for my diamond, 2.42. Can't do that. 1.00 divided by 2.42 is equal to 24 degrees. So any angle bigger, any theta 1 leaving the diamond greater than 24 degrees will be internally reflected. And we'll finish this up in the next. Okay? All right. Cool beans. We're done here.